Welcome to NASA LaunchPad. I'm your host, Jamie. Living and working anywhere can sometimes be a challenge, but some places are harder than others. Think about living or working here in Antarctica, or here in the desert, or here on the moon. What's it going to take to live and work on the surface of the moon? NASA's really working to answer that question as it prepares to return there. And one thing's for sure, to get back to the moon, astronauts are going to need lots of equipment, even some things that haven't been invented yet. With some potential lunar equipment in tow, NASA scientists rolled out to the lunar-like landscape of Moses Lake, Washington, to put the equipment through its paces. One piece of equipment tested was the Lunar Surface Manipulation System, or the LSMS. Even though it looks like a basic crane, it's slightly more complex. It's a crane, a shovel, and a forklift. And who knows what else it can be? It's still evolving. One thing's for sure, it's smart. The LSMS can operate on its own, or it can be operated remotely from a base. And as a backup, astronauts can even control it manually. This machine is massive. Its arm has a horizontal reach of 7.5 meters and a vertical reach of almost 9 meters above the surface of the moon. That's taller than most houses here on Earth. And the arm is strong too. It can lift 150 kilograms while it's here on Earth, and can lift even more when it's on the moon and Mars. It's designed to move 500 kilograms on Mars and 1,000 kilograms on the moon. How can that happen? No, the arm isn't getting stronger. The weight of what it's lifting is changing. Confused? Let me explain. Weight is really a measurement of gravity pulling on matter. Let's pretend you wanted to lift 120 kilograms. That's about the size of a defensive linebacker. Big, really big. Now, a kilogram is really a measurement of mass, so let's look at the metric unit of weight, the Newton. So on Earth, the 120 kilogram linebacker would weigh about 1,200 newtons. On the moon, that same linebacker would only weigh about 200 newtons, because the moon's gravitational pull is only 1/6 that of Earth. Now, take him to Mars, and it's only 1/3 of Earth's gravity. So he'd only weigh about 400 newtons. Make sense now? No matter where the LSMS might be, it's powerful and smart, strong enough to lift everything from communications and power equipment, airlocks and habitats, to even a lunar rover, smart enough to steer itself. Another piece of equipment wheeled out for testing is this little guy. That's one of the K-10 rovers. These are scout robots, which may map the surface or check around for new scientific discoveries. These jobs may be highly repetitive and take a long time, the kinds of jobs you wouldn't want to make people do over and over and over again.
This robot is a robot that we could send into places on the moon where we're not sure we want to risk crew, for example, into deep, dark craters. This robot's actually equipped with several different kinds of instruments to look at the environment. It's got a laser scanner that creates these 3D models of the terrain. That scanner can see out about 5-6 blocks and see things as small as a pencil eraser. It's also equipped with 4 different cameras. One on top is taking panoramic images of the area. Another one is looking down at the ground, taking images of the terrain that allows scientists to compare different areas that we explore. And then in the very front are 2 cameras that we use for navigating. Just like humans use our 2 eyes to see where we're going, this robot uses 2 cameras to figure out what's safe and what's not safe.
Here's one more piece of equipment NASA tested out at Moses Lake. This one's called a Scarab, like the beetle. Scarab carries a 1-meter drill and scientific gear that allows it to look for materials like hydrogen and oxygen. It can explore craters and other dark areas of the moon. A new and improved Scarab will have a laser system that will help it map the moon's surface and steer without seeing. So, these are just a few of the technologies tested by the Exploration Technology Development Program Office. Of course, not every piece of gear tested will make it to the moon. But everything learned by designing, making, testing, and redesigning this equipment will be used in some way or another. That's one of the best parts about creating new things for space travel. Scientists and engineers learn so much just by working to solve the problems of taking people back to the moon. Besides equipment like these pieces tested at Moses Lake, what else do you think astronauts will need to bring with them? What would you bring if you were going to the moon? Think about it. Until next time, I'm Jamie, and thanks for watching NASA LaunchPad.